Jupiter, the fastest spinning planet in our solar system, with a day lasting only 10 hours. The biggest planet in our solar system, a gas giant more than 300 times as massive as Earth. It has rings of dust and colorful bands stretching across its surface, which are actually gases. And then there's the Great Red Spot, iconic raging storm, huge hurricane, 2 to 3 times as wide as the whole Earth. It's also insanely deep and goes around 300 miles into Jupiter's atmosphere. That's 40 times as deep as the Mariana Trench, the deepest oceanic spot on Earth. Way more extensive than scientists expected. Researchers have speculated about the Great Red Spot for hundreds of years already. This storm is circling Jupiter in its southern hemisphere. At the center of this giant spinning storm, the winds are relatively calm. On the edges, wind speeds go up to 425 miles per hour. That's twice as faster than the strongest hurricanes on our planet, 175 miles per hour. When there's a hurricane on Earth, it goes wild at first, but eventually starts to slow down. It finally breaks apart when it reaches solid land. Jupiter has a sky that's 44 miles deep. There are layers of clouds, and beneath them, scientists believe, lies an ocean of liquid hydrogen. The planet's core is supposed to be right under that ocean, but we're still not sure what exactly it's made of. As far as we know, Jupiter is a gas world, so there's no solid ground that would stop the storm. That's why the spot continues to rage on and on. Scientists realize the storm is constantly changing its size. Compared to data from 1850, it's shrinking right now. The Great Red Spot used to be 3 times the size of Earth. It's been a long time since it last got bigger. As it's shrinking, the storm gets taller and changes color into an intense orange, possibly because of the chemical reactions. New matter raises from the bottom of the storm. The red Great Spot could continue shrinking and eventually disappear in the next 10 to 20 years. But there could be another similar storm emerging somewhere else on Jupiter, if the red Great Spot ever ends. This storm might seem very deep, but it's still shallower than the giant jets of wind that rage around it and power the storm even more. Jupiter's bands of wind go to depths of 2,000 miles below its cloud tops. Jupiter is generally known for having crazy windy conditions in the upper and lower parts of the atmosphere. The middle part is called the stratosphere, and we didn't know what was going on there. Scientists usually measure wind power by watching clouds, and there are no clouds in the stratosphere. But when a comet, Shoemaker-Levy 9, collided with Jupiter in 1994, scientists got a chance to study cometary structure and composition and its effects on Jupiter's atmosphere. They discovered insanely strong winds in the stratosphere with speeds of 900 miles per hour. Jupiter isn't the only planet in our solar system with crazy weather. Mars has the biggest dust storms amongst all 8 planets. When such a storm is raging, it seems like it creates a blanket over the entire planet that lasts for months. One theory that tries to explain why dust storms are so big on Mars says airborne particles of dust absorb sunlight and warm the planet's atmosphere. This creates warm pockets of air. They start flowing toward colder areas, which then generates winds. These winds lift dust off the ground, which heats the atmosphere, makes winds stronger, and kicks up more dust. Mars generally has a very thin atmosphere. It mostly consists of carbon dioxide, and the volume of gases in the Martian atmosphere is less than 1% of that of our planet. But Mars used to be much wetter and warmer than it is today. That means its atmosphere was much thicker. A long time ago, it created a strong greenhouse effect and trapped the sunlight. Mars used to have a pretty strong magnetic field. Just like on Earth, the magnetic field on Mars was created by currents of molten metals in its core. But unlike our planet, the inside of Mars cooled enough to switch off the magnetic field. Without it, Mars wasn't protected from the solar wind. That's a powerful stream of particles flowing from our sun. It took only a couple of 100 million years, which is not much in space terms, for the solar wind to strip away most of the atmosphere on Mars. It went quickly because the sun used to rotate much faster at its earlier stages, so the solar wind was more powerful and energetic. And that's how Mars turned from a planet with a warm, wet climate into the cold, dry place it is today. Mars also has some interesting glaciers. They've been on its surface for hundreds of millions of years and can tell us secrets of the planet's past. For instance, that's how we found out Mars went through 6 to 20 separate ice ages during the past 300 to 800 million years. Satellites took images of 60,000 rocks of different sizes. They were distributed across the entire planet at random. If Mars had a single, long ice age, we'd find a progression of bigger to smaller rocks because they erode as time goes by. But the rocks were spread in clear bands of debris across the surface of these glaciers. Each band marked the different flow of ice, which means each of them formed during a different ice age. These glaciers are like time capsules because they could have all kinds of gases, rocks, or even microbes trapped inside. That means they could help us understand the changes in climate on Mars and tell us if there used to be any form of life on the planet. And the best thing, we don't need to drill deep down below the crust to find that out. Everything's on the surface. If you could go back in time, let's say 4 billion years, and visit the red planet, you'd probably see chaotic scenes of flooding. Scientists believe that megaflood happened because of a huge meteoritic impact. Because of the heat from that impact, ice on the planet's surface started melting. This flood carved out big ripples and waves in the sedimentary rock. Some wave-shaped features are over 30 feet high and spaced out 450 feet apart. Saturn also has its own unique weather conditions. Lightning bolts there can be 10,000 times more powerful than the ones we have on Earth. NASA's Cassini spacecraft was orbiting Saturn from 2004 to 2017. It captured lightning so strong and intense, we could see it even during the daytime. Cassini also recorded the sounds of those intense storms discharged into the planet's atmosphere. From time to time, Saturn has giant storms that go over 190,000 miles across the surface. They encircle nearly the entire planet. On Saturn's North Pole, there's a massive hexagon of clouds. It's a vortex of a pretty unusual shape that circulates hundreds of miles above the clouds and extends deep into the planet. But Saturn has its peaceful side too. Along with Jupiter, Uranus, and Neptune, it has its own beautiful auroras from time to time. All 4 planets have an atmosphere dominated by hydrogen. That's why you can only see these auroras in ultraviolet wavelengths. These northern lights are especially bright at dusk and right before midnight. Venus has a giant storm swirling in the atmosphere at its south pole. The vortex is as big as the entirety of Europe, and it's probably been there for a very long time. The atmosphere on Venus moves 60 times faster than the planet rotates. Venus is the hottest planet in our solar system. Even the rain there offers no relief, since it's sulfuric acid falling from clouds and evaporating before it even gets to the ground. The sun also has its own angry outbursts in the shape of powerful solar storms. These storms bring strong radiation and dust particles that can cause serious damage to satellites that track the sun's activity to let us know if something goes wrong. Every now and then, a crazy solar storm can catch us off guard. About 160 years ago, a strong solar flare caused severe issues in global telegraph communications. About 30 years ago, a solar flare left 6 million people without electricity for 9 hours. One theory says strong solar activity could have caused the sinking of the Titanic. It happened on the same night as a fascinating northern lights show. Some people believe a solar storm behind it had possibly disrupted the ship's communication systems and navigation, leading to one of the greatest unsolved mysteries ever.
Did you know that the moon is rusting? No, not rustic, rusting. Well, that sounds impossible because rust needs oxygen, and the moon, well, it doesn't have it. Or so we thought. Apparently, Earth is leaking its air, and it's marinating the moon. It might have been like that for billions of years. What does this mean? And why do scientists say it's great news for a future lunar base? Well, let's find out. A few years ago, the Indian Space Research Organization sent a probe called Chandrayaan-1 to orbit the moon. Its mission was to take some nice pictures, but it also was carrying a NASA-built instrument designed to chemically map the surface. The readings came back showing something scientists didn't expect on the moon: hematite. It's an iron oxide, or in plain words, rust. It's the same red, rusty material that eats through your garden fence or a forgotten bicycle chain. Finding rust on Earth is normal because our planet is wet and airy. You need a strict recipe to make it happen. You need iron, you need water, and you need oxygen. The moon already has the first ingredient for rust because its surface is rich in iron from billions of years of asteroid impacts. But the other 2 ingredients are missing. There is no atmosphere to provide oxygen, and there is no liquid water gathering on the surface. But it goes beyond that. Space actually hates rust. The sun constantly blasts the moon with the solar wind, a stream of fast particles made mostly of hydrogen. Well, these particles tend to strip oxygen away from rocks instead of adding it. All of that makes it obvious why hematite doesn't belong anywhere near our satellite. But these results don't lie. The presence of hematite means that somehow, despite the vacuum and the sun's particle stream, the moon is getting a steady supply of oxygen. It's not coming from deep space or the lunar core. Also, the rust isn't spread evenly. The data showed that the hematite is more concentrated on the side of the moon that faces Earth. The far side is mostly clean. Now, the only oxidizer close enough to do the job is Earth. We learned at school that Earth's atmosphere ends at the Kármán line, about 62 miles up. That's where space officially begins. But that's just the thick part. In reality, Earth is wrapped in a gigantic invisible cloud of hydrogen called the geocorona. It's enormous. It glows in ultraviolet light, and it stretches almost 400,000 miles into space. That's farther than the moon's orbit. This means that despite being very far away, the moon is still within the outer edges of Earth's atmosphere. If you were standing on the moon, looking back at Earth with a telescope that can see ultraviolet hydrogen, Earth wouldn't look like a blue marble. It would look like it's wearing a huge, fuzzy, glowing halo. Now, when we picture Earth and the moon, we imagine a huge, clean gap between them. Two worlds separated by nothing. But that nothing isn't actually empty. The two are already connected by gravity, tugging on each other nonstop. But there's another kind of connection most people never think about. Earth is surrounded by an invisible force called a magnetic field. It's created deep inside the planet and stretches far out into space. We don't see it, but it's the reason compasses work and the sun doesn't strip our atmosphere away. This magnetic field doesn't just stop at Earth's surface. It doesn't sit there like a perfect bubble either. The solar wind pushes on it non-stop, stretching it out behind Earth into a long magnetic tail that reaches hundreds of thousands of miles into space, like a tail trailing behind a moving comet. That tail is how Earth's oxygen ends up on the moon. The sun slams into Earth's upper atmosphere, knocking oxygen and nitrogen atoms loose and turning them into charged particles. Normally, they'd drift off into space, but because they're charged, Earth's magnetic field grabs them and sends them backward, down the magnetic tail. Most of the time, the moon is off to the side doing its own thing. But once a month, right around the full moon, it slides straight into Earth's magnetic ponytail. Inside that tail, Earth blocks the harsh solar wind and gives the moon a few days of calm. But it's still moving straight through particles leaking from Earth. Those particles collide with the surface and react with the iron in the soil. Repeat that long enough, and it adds up. Earth loses tiny traces of its air, and the moon quietly collects them using its weak gravity like a slow, patient net. It's like driving behind a dirty truck. Dirt flies off of it, but you don't really notice until it starts sticking to your windshield. The same thing happens on the moon, except, no windshield. We actually have proof of this happening in real time. A Japanese probe called Kaguya was hanging out in lunar orbit, and its sensors spiked when the moon passed through Earth's magnetic tail. It detected a surge of high-energy oxygen ions. Scientists call it the Earth wind. It acts like the solar wind, except instead of being hot particles from a star, it's made from leftovers of our own atmosphere. And this suddenly makes the moon part of a much bigger story. Scientists think this kind of atmospheric escape can help explain what happened to planets like Mars. The red planet doesn't have a global magnetic field today, but long ago it probably did. When that shield failed, its atmosphere had a much easier time leaking away. Studying Earth and the Moon is like watching a version of that process on replay, just in slow motion. And it's not unique. Near the edge of the solar system, Pluto's thin atmosphere is slowly being stolen by its moon Charon. Ooh, larceny in space. Pluto's gravity is so weak that its atmosphere stretches far into space. When those gas particles drift close enough, Charon's gravity simply grabs them. No magnetic field needed, just a leaky planet and a nearby moon pulling the material away. Now, when the Apollo astronauts brought lunar soil to Earth, it was already loaded with hydrogen from the solar wind. The sun sprays the lunar surface with hydrogen, and over time, that hydrogen gets baked straight into the dust. That's the H, but you still need the O2 to create water. The regolith may already contain trace amounts of oxygen locked into minerals and dust, not as ice, but as something that can potentially be processed. It would mean that regolith is not just a nuisance that destroys gear and rovers. For a future lunar base, even small amounts matter. Water is heavy. Launching it from Earth is a nightmare. If the moon can supply even part of what astronauts need, it could make a difference. Now, another cool side effect of this discovery is that drilling into the moon could tell us more about Earth's history. You see, our planet is terrible at keeping records. It's like a giant recycling machine. It's always changing. Tectonic plates grind the crust down and melt it into magma. Winds and rains erode rocks. The air that we breathe now is different from the one that was around 2 billion years ago. Now, we can guess what the ancient atmosphere was like, but we don't have a physical sample. The moon is the complete opposite. It's cold and static. When those Earth particles land on the moon, they get buried under dust and stay there. They're trapped in the crystal lattice of the soil. Think of the lunar surface like an ice core in Antarctica. The deeper we dig, the further back in time we go. If we drill a core sample on the moon, we might, theoretically, find layers of oxygen and nitrogen from 2.5 billion years ago. That is right around the Great Oxidation Event, when microbes first started pumping oxygen into our atmosphere. That could tell us something we don't know. It could prove that life started earlier than we thought. It could show us exactly how a dead planet turns into a living one. That's another answer you can give the next time somebody asks why we should go back to the moon. Also define the green cheese. Hey, just Google it.
Let's take a little satellite, tie it to the shuttle with 12 miles of cable, and send it for a spacewalk. It might sound like another crazy plot for a YouTube hit video, but this idea actually belonged to NASA. In 1996, they teamed up with the Italian Space Agency to try one of the boldest, strangest experiments ever attempted in orbit. The mission was called TSS-1R, short for Tethered Satellite System 1R. They came up with a plan to reel a satellite from the Space Shuttle Columbia on a tether that could carry an electric current. As the shuttle zipped around Earth, that long cable would slice through the planet's magnetic field lines. In physics terms, moving a conductor through a magnetic field generates electricity. So, the Space Shuttle Tether Satellite combo was about to turn into a giant orbital power generator. It was like plugging an extension cord into Earth's invisible magnetism. The physics behind this craziness was rock solid. Engineers hoped this tether would pump out usable power, maybe even thousands of volts. If it worked, it could change how spacecraft get electricity or inspire new ways of braking in orbit using electrodynamic drag. So, launch day came. Columbia lifted off. The crew prepared the system, and they started letting the satellite out on its long, long cord. At first, it was smooth sailing. The satellite glided away, the tether unreeled like a spool of cosmic fishing line, and the science team was buzzing with excitement. As the line stretched longer, it started generating more and more electricity, over 3,000 volts at its peak. Everything was running perfectly like a dream experiment. And then, just as the tether was almost fully extended, nearly the full 12 miles, things took a dramatic turn. A localized electrical discharge zapped through the tether's insulation. The cable arced and burned a hole right through itself, and with one fatal snap, the tether broke. Just like that, the grand experiment was toast. The crew could only watch as the little satellite, still trailing its dangling wire, floated off into space like a lost balloon on the world's longest string. Years of hard work preparing the experiment just literally drifted away. Visually, it was almost comical. Reporters couldn't resist calling it the goofiest space experiment in history. And honestly, they weren't wrong. It looked less like cutting-edge space technology and more like someone had tied a toy to a string and let it loose above Earth. But, goofy or not, the experiment actually proved the physics worked. Before the failure, the tether really did generate significant electricity, exactly as the scientists predicted. Over 3,000 volts coursed through that cable before it fried. The idea of using conductive tethers for power and propulsion in space wasn't a fantasy. It was all real. The problem wasn't the science, it was the engineering. Space is an unforgiving place, and one small weakness in insulation was enough to take down the whole mission. Even though TSS-1R ended with a literal snap, it left behind valuable data. Engineers learned more about how tether systems behave in orbit, and the concept is still alive today. Researchers keep looking at space tethers for everything from satellite deorbiting systems to futuristic power stations in orbit. So that broken cable might have been a letdown in 1996, but it wasn't the end of the story. If a satellite on a cable isn't wild enough for you, how about 2 golden orb weaver spiders on the International Space Station? In 2011, NASA sent these 2 cuties, called Gladys and Esmeralda, up there on Shuttle Endeavour, just to see, can spiders spin webs in microgravity? Turns out, yes. The experiment lasted 45 days. While floating in orbit, the spiders went ahead and spun webs, but the webs looked shockingly symmetrical, perfect circles, rather than the slightly lopsided webs they usually make on Earth. The spiders, deprived of down and up, used light inside their habitat to orient themselves. On Earth, spiders use gravity to guide how they stretch their legs and spin out their web lines. But in space, with no gravity to rely on, they looked at the lamps and used that as their ground. But that experiment in 2011 wasn't the first space adventure for spidernauts. Way back in 1973, NASA launched 2 female European garden spiders called Arabella and Anita into space aboard Skylab 3. The idea of this experiment actually came from a 17-year-old high school student in Massachusetts. The spiders were stashed in little containers and then coaxed into a special tank to spin webs while orbiting Earth. At first, Arabella struggled. She took a while to adapt, and the first web she spun was incomplete. But by the next day, she managed to finish it. Over time, the webs she produced were finer and more delicate than normal Earth versions, and scientists noticed subtle differences in thickness across the threads. But NASA wasn't just curious about spiders for the sake of, spiders. Scientists wanted to figure out how near microgravity messes with the central nervous system. Not just in spiders, but in animals in general, humans included. Spiders actually make the perfect test subjects because their webs are basically brain maps in silk. You can tell how well the spider's nervous system is working just by looking at the shape and quality of the web it spins. On Earth, a spider has a whole toolkit. It knows how heavy it is, so it figures out how thick the silk needs to be. It uses wind and gravity to decide where to anchor and how to stretch the lines. But the way spiders adjusted to build webs in 0G gave clues about how our own motor systems and brains might behave if we had to live long-term in space. Sadly, Arabella and Anita, the first 2 spidernauts, did their job, spun webs, gave us tons of data, but didn't survive their mission. The likely cause was dehydration. On a brighter note, scientists have grown everything from lettuce to yeast on the ISS. But one of the oddest was trying to see if fungus could shield astronauts from radiation. They took samples of a fungus that thrives in places with high radiation and monitored how it reduced radiation passing through it. Over a thin layer of this fungal mat, radiation levels dropped by about 2.17% compared to a control sample. At the same time, the fungus had around a 21% growth boost in microgravity. So not only did it block some radiation, it actually seemed to use radiation to fuel itself, almost like a weird fungal solar panel. Now, you might ask, why fungi? Why not steel or lead? because living things self-repair, self-replicate, and adapt. If you could grow stuff that helps shield you from radiation while it's doing other jobs like repairing and evolving, that's gold for long space missions. The idea is, maybe astronauts could grow part of their radiation shield using organisms, instead of hauling tons of heavy shielding materials into space. There was also broader research catalogs on space fungi and microbes. One study in 2019 cataloged all the bacteria and fungi found inside the ISS, on walls, equipment, windows, sleep stations, you name it. They found the fungal communities were pretty stable over time. That means fungi are not just surviving, but persisting in that closed, harsh space environment. This science experiment is like a hint that we could have a future where biology and engineering mash together. If we can harness fungi or other organisms as part of a spacecraft structure, we open up a whole new way of designing space habitats. Instead of walls you build once, you could have walls that grow. To make radiation levels Earth-like on Mars, you might need a 7.5-foot thick layer of this fungus covering a habitat. That's huge, but maybe easier than dragging tons of lead through space. There's a lot to figure out about safety, control, dose limits, and how this would work long-term. But in the future, astronauts might live behind walls of living mushroom shields, literally harnessing biology to survive the void. You look up at the night sky and see nothing. Okay, well, it's not nothing. You see stars, but not nearly enough. If the universe is filled with endless stars in every direction, why isn't the sky blazing with light? That's just one of many cosmic riddles that are still waiting for an answer. Why do black holes delete information? Why can't the universe agree on how fast it's expanding? Yeah, these paradoxes break rules so much that it feels like they're breaking reality itself. The universe is endless, right? Just stars on stars on stars stretching out into infinity. Well, if that's the case, then how come the night sky isn't lit up like Times Square on New Year's Eve? That's the heart of Olber's paradox, named after 19th century astronomer Heinrich Olbers. He wasn't the first to notice the problem, but he made it famous by basically asking, if there are stars in every direction, shouldn't the whole sky be glowing? You might think they're just too far. But in an endless universe, every direction should eventually hit a star, and all that faint light should add up. So, why the darkness? Maybe the answer is that the universe isn't infinite in time. It had a beginning, the Big Bang. That means light from the most distant stars hadn't had enough time to reach us yet. And the light that has been traveling for billions of years, it's been stretched out so much by the expanding universe that it's now invisible to our eyes. So, that pitch black sky? It's not empty. It could be that it's full of light. We just can't see. Maybe it's a clue, a sign that the universe has a beginning, a history that we have yet to uncover. Alright, so space is darker than it should be. But you know what's even weirder? It's also way too quiet. You probably wondered about this since elementary school. Okay, the universe is massive. There are billions of stars with planets orbiting them. And a bunch of those planets should be kinda like Earth, which means extraterrestrials, right? So, where are they? This is what we call the Fermi paradox. Back in the 1950s, physicist Enrico Fermi sat down and asked himself this very question. There are no signals from outer space, no laser beams, no weirdly coded messages, nothing. It's not like we haven't tried to say hello. In 1974, scientists used the giant Arecibo radio telescope to beam a binary-coded message into space. It included stuff like our DNA structure, a stick figure of a human, and even Earth's location in the solar system. And since sound can't travel in space, what we actually sent were radio waves traveling at the speed of light. The message is heading to a star cluster 25,000 light-years away. So even if those little green men pick it up the moment it arrives, the earliest we could get a response is in about 50,000 years. Okay, that's pretty far into the future. But wait, if we're out here sending signals, Isn't it possible someone else did the same, like 150,000 years ago or 500,000? Shouldn't something have reached us by now? Some extraterrestrial TikTok at least? The answer could be that we're the first technologically advanced civilization. Perhaps intelligent civilizations vanish with their stars. Or maybe they're not as friendly as we are, and they've been avoiding us for a reason. Here's a nerdy one. Maybe they're out there, but we're just not listening the right way because it's not us being advanced enough. What if extraterrestrial civilizations communicate using something completely different from what we do? Like quantum entanglement or some exotic tech we haven't even dreamed of yet. Or maybe they exist in a form we can't even comprehend. Anyway, let's move from the silence of space to its most terrifying feature: black holes. You've probably heard the basics. Black holes are regions of space where gravity is so intense that not even light can escape. But here is an interesting theory. Black holes might be breaking one of the most sacred rules in all of physics. It's called the black hole information paradox, and this one made my brain hurt. In quantum physics, there's a rule. Information can't vanish. Not diary secrets, but the data describing every particle's position, spin, and motion. The whole essence, so to speak. Even if you destroy something, like burning a book to ash, the atoms and energy are still around. And in theory, big emphasis on theory, if you had super advanced tools, you could still figure out what was written in that book based on the particles and energy left behind. But when something falls into a black hole, a star, a spaceship, a giant pizza, whatever, it disappears behind the event horizon. And then, over time, the black hole itself slowly evaporates by releasing tiny bits of energy called Hawking radiation. Here's the problem. Hawking radiation dribbles out like random static, carrying no obvious hint of what the black hole swallowed. And if the black hole disappears completely and that information never comes out, it's like the universe just deleted the file with no backup. That breaks the no information loss rule. Some scientists think the information might be hidden in the radiation, but scrambled in a way we don't understand yet. Others think it gets imprinted on the surface of the black hole. And some say maybe we've got something fundamentally wrong about how the universe works. Before we figure out that one, let's pull back from black holes and take a wider look at the universe itself. Because even the way it's expanding doesn't seem to add up. This one is called Hubble tension, and it's not about drama between scientists. It's about a simple question. How fast is the universe expanding? Now, this should be easy to measure, right? For people good at math, I mean. Turns out, scientists have two ways. One looks at the early universe using the glow left over from the Big Bang. The other checks how fast galaxies are moving today by watching exploding stars. Except here is something funny. Those two numbers don't match. You'd think maybe it's just a measuring glitch, like, oops, forgot to carry the 1, but nope. It's more like checking the speed limit sign and then pointing two radar guns at the same car, and both showing vastly different results. This cosmic disagreement might mean that dark energy, the thing driving the expansion of the universe, is changing over time. Or that there's some secret ingredient baked into the early universe we haven't discovered yet. Either way, the universe seems to be expanding in a way that breaks our models. So it's possible we're missing something big. Or that reality is playing by guidelines we haven't written down yet. Alright, we've talked about how black holes might erase information. However, there's something just as weird. What if things in the universe don't decide what they are until you look at them? That's basically the idea behind the observer effect. Imagine you're tossing tiny balls at a wall with two holes in it. You'd expect each ball to go through one hole or the other, right? But if those balls are actually particles, like photons or electrons, something weird happens. If no one's watching, they act more like waves, and they go through both holes at the same time. But the moment you try to watch them, they stop doing that. They choose one hole and act like regular balls again. It's as if reality holds its breath until we look, then locks in what it is. But were they? Or did our act of looking force the decision? Nobody's really sure. However, that's not all. We didn't even have time to get into the time symmetry paradox, where the math says time should flow both ways, but in real life, it only marches forward. Or the cosmic horizon paradox, which asks how far apart regions of the universe, too far to ever communicate, somehow ended up looking exactly the same. Or the simulation hypothesis, which, let's just say that one deserves its own video. These paradoxes aren't just cool thought experiments. They're clues, little cracks in the surface of reality. And that's what makes it so exciting. See you next time. A giant wormhole, or simply said, a connection between regions of space-time, opens up in space near Earth. Our world faces chaos unlike anything before. Satellites incinerated, skies ripped open by radiation storms, entire power grids blacked out. The atmosphere is swelling and scorching, the oceans are boiling, the magnetic shield is shattering. Suddenly, the wormhole destabilizes. Space-time starts to unravel, tearing Earth apart from the inside out. People are seeking shelter, but nothing can save them anymore. Look at this devastation. This isn't just a sci-fi scenario. It's a cosmic apocalypse waiting to happen and rewrite the fate of humanity. The thing is, some black holes might actually be secret space portals. It may sound like something straight out of Stranger Things, but it's not. Scientists have been wondering for years if some black holes could actually be wormholes in disguise, tunnels through space and time. And now, a new study says this might actually be possible, at least in theory. Wormholes are like cosmic shortcuts that let you pop out in a totally different part of the universe. Unfortunately, we've never found one, and the whole concept still lives in the land of what if. Here's the problem. To actually make a wormhole work, you'd need something called negative energy. That's not just rare. It doesn't even exist in the regular universe. Maybe in some weird world of quantum physics, but even there, it's super uncertain. Still, scientists have a wild thought. What if some black holes aren't just giant space vacuums that swallow everything around them, but are really hidden wormholes? The odds of that are tiny, like winning the lottery while getting struck by lightning and discovering extraterrestrials at the same time. But mathematically, it's not impossible. That's where the new study comes in. Researchers looked at a weird type of black hole called a Schwarzschild black hole. These ones don't spin, don't have electric charge, and, very predictably, are totally hypothetical. They're just the math version of a black hole, not something we've seen in space. In any case, the team studied something called quasi-normal modes, which is just a fancy way of saying how space vibrates around a black hole when you mess with it. These vibrations don't go on forever. They fade out like the ringing sound you get when you hit a bell. By analyzing those space-time vibes, scientists tried to figure out if they could tell the difference between a regular black hole and a wormhole pretending to be one. It turns out that it's super hard to tell this difference. But maybe that's the point. Wormholes might be hiding in plain sight, wearing black hole costumes like it's space Halloween. Wormholes could copy a black hole's behavior almost perfectly, at least on paper. The researchers uploaded the whole study to Arxiv, which is where science nerds drop their ideas before they hit the big journals. And it's already been published in Physical Review D, which is a serious physics magazine. The coolest thing, though, is that it isn't a brand new idea. Scientists have been debating this whole black hole or wormhole thing for decades. Back in 2021, some researchers wondered if the giant black holes at the centers of galaxies, called active galactic nuclei, were actually wormhole entrances. And in 2022, a team in Bulgaria said that the light coming from a wormhole could look almost exactly like what comes from a black hole. There's also this sci-fi level theory that some black holes might be paired with opposite twins, called white holes. A white hole basically spits stuff out instead of sucking it in. Together, a black and a white hole could form a wormhole tunnel. But no one's found a white hole either yet, so that idea is still just theory. By the way, in this latest study, the authors have shown that wormholes and black holes not only look similar, but also sound similar, at least in how space-time shakes around them when they get hit with something. So our next move should be fine-tuning our scientific models, especially near the part of the wormhole called the throat. Scientists want to see if wormholes could fake even more black hole-like behavior, but it's tricky. Some of the math gets super hard. In any case, how about finding out more about these mysterious wormholes? You've seen them in every second sci-fi movie, magical space tunnels that let you skip across the universe. Einstein was the first one to have dreamed them up. Wormholes are still 100% hypothetical, and we've never spotted one. But that doesn't stop people from theorizing. Like, what if a wormhole started sucking in matter like a black hole does? If a wormhole started eating stuff like dust, gas, or space debris, it would create a plasma tornado, a literal space firestorm in its throat. And this twisty storm would eventually blast out the other side of the wormhole, firing hot plasma at nearly 125 million miles per hour. That's about 1/5 the speed of light. It would also be insanely hot in there, so hot it could probably trigger nuclear fusion. Of course, all of this is still just theoretical. No one's seen a wormhole do this. No one's seen a wormhole do anything, actually. But the math says it could happen, if we ever find a wormhole. The bright side of it all is that we would probably spot an event with so much drama. Even though wormholes don't have an event horizon, aka the point of no return, like black holes, they still bend light. Normally, you might not be able to see something like that, but this thing is so absurdly bright from the plasma firestorm that you would actually see it glowing in space. Think of it like a black hole, but with a glowing center instead of just darkness, and a jet of flaming plasma shooting out one side like a broken space faucet. Still, don't get your hopes up for spotting one anytime soon. Even if we did find a wormhole, it probably wouldn't last long. It could break apart or transform into a completely different type of space-time before we even realized what we were looking at. Plus, keep in mind that wormholes might look almost exactly like black holes unless you know what kind of light polarization, how light waves line up, to look for. Now, let's talk a bit more about black holes themselves. You're likely to know them as insane space beasts that suck up everything nearby: gas, dust, even light. And once something crosses a black hole's event horizon, it's trapped forever. Scientists say that inside, everything gets crushed into a tiny point called a singularity, where the usual rules of physics totally break down. But back in 2010, a physicist named Nikodem Pawlowski had a crazy idea. What if black holes don't have singularities? Instead, what if the center of a black hole is actually a doorway to another universe? Maybe our entire universe was born from matter shooting out of a black hole in some parent universe. Pawlowski's theory uses something called torsion, which is like a weird gravitational twist that stops matter from getting crushed infinitely. Because of torsion, instead of crashing into a singularity, matter inside a black hole can create a tunnel, a so-called Einstein-Rosen bridge, or simply a wormhole, connecting a black hole to a white hole. So, imagine matter falling into a black hole in one universe, then popping out of a white hole in another. Pawlowski thinks this could explain the Big Bang, but as a big bounce, meaning the universe keeps cycling through phases of expansion and contraction, not just one huge explosion. Sadly, if such a tunnel existed, it would be a one-way trip. Nothing would come back through to the original universe. Some scientists are still skeptical because torsion hasn't been proven yet, but other experts think Pawlowski's model is super promising. They even go further and say that our whole universe might be living inside a giant black hole hundreds of billions of light years wide. Now, we just need to figure out how to test this. Future space studies might give us more clues, like checking if our universe is closed, which basically means that it's curved without an edge, or digging deeper into cosmic background radiation, which is the leftover glow from the Big Bang. A huge invisible danger zone is hanging above Earth, messing with satellites, zapping electronics, and giving astronauts a headache. Scientists call it the South Atlantic Anomaly, and it's kind of like the Bermuda Triangle of space, because weird stuff happens there and nobody fully understands why. Want to know more about this thing? Well, Earth has a magnetic field that protects us from dangerous radiation from the sun. We'll talk about it later. And over one spot on the planet, right above the South Atlantic Ocean, that shield gets weirdly weak. It stretches over South America and parts of Africa, creating a sort of magnetic soft spot. That weak spot is bad news for anything flying up there. When satellites travel through it, their systems can freak out. Computers freeze, data gets scrambled, and sometimes entire instruments shut down. Basically, the space version of your phone glitching out right when you need it most. Astronauts have to be extra careful in this region too. When the International Space Station passes through the anomaly, radiation levels spike. It's not enough to fry anyone, but it's surely not fun. The equipment can take a serious hit. No one knows exactly what's going on yet, but scientists think the SAA might be a clue that Earth's magnetic field is shifting. If that's true, it could mean big changes for the future, for us all. You see, the South Atlantic Anomaly is connected to Earth's molten insides. Deep beneath the surface, the planet's core and mantle are constantly moving, flowing, and clashing. The outer core is a swirling ocean of liquid metal, and the mantle above is hot, solid rock. Under Africa, there's nothing to cool things down. The mantle is hotter than usual, which creates certain instability in the magnetic field above. As for South America, there, the Nazca Plate is dragging rock and debris down toward the core. This cools things off and keeps the field more stable. Such a wild temperature difference seems to be fueling the anomaly. According to some sources, it drives it across the Atlantic. The anomaly is slowly drifting westward. The thing is, Earth's magnetic field protects us from dangerous radiation from space, powerful solar winds, and wild swings in temperature, and keeps our atmosphere in check. But over millions of years, the magnetic poles have flipped. When it happens, north becomes south, south becomes north, and during those flips, the field can weaken. And some scientists thought the South Atlantic Anomaly might be a warning sign before a full magnetic reversal. It could mean disaster to humans, but we'll talk about it later. The good news is, these flips take over. On average, Earth flips its magnetic poles about 2 times per million years. That means the next reversal could be hundreds of thousands of years away. Nearly 600 million years ago, our planet's shield almost failed, but at that time, it could have been a good thing. Scientists think this near collapse might have triggered a massive evolutionary boost and helped the first complex life forms to evolve. Back then, during a period called the Ediacaran, the magnetic field weakened drastically and stayed that weak for about 26 million years. With less protection, solar radiation removed lighter gases from the atmosphere, leaving oxygen floating freely in the air and oceans. That oxygen helped the first multicellular oxygen-breathing organisms to see the light of day. Those were strange, squishy creatures that hardly resembled animals today. Some were disc-shaped blobs, fronds, or shapeless fans, stretching over 3 feet long. By the way, one of the earliest known animals, Dickinsonia, was among them. It looks kinda pretty, doesn't it? Now, how do we know all this? Thanks to rocks. They're like time capsules. Tiny crystals inside them preserve the power of the magnetic field from hundreds of thousands of years ago. For example, certain crystals from southern Brazil revealed that 591 million years ago, Earth's magnetic field was 30 times weaker than it is now. And rocks from South Africa dating back 2 billion years showed that the field was at full strength back then. Now, let's explore a bit. Deep beneath our feet, there's Earth's inner core. We're used to thinking about it as a perfect solid ball. but new research suggests it might be changing shape. Over the past 20 years, parts of the inner core may have bulged or dipped by more than 300 feet. That's like a skyscraper popping up or sinking deep underground inside the planet. This core spins independently from the outer liquid core, which creates the magnetic field that shields us from dangerous solar radiation. The magnetosphere is non-negotiable. Without it, Earth would lose its atmosphere over time. Water would vanish, and life as we know it wouldn't survive. It basically keeps the planet alive. Without it, Earth could turn into a barren Mars, which lost its magnetic field billions of years ago, and along with it, almost all its atmosphere. So why is our planet's inner core deforming? It seems to happen where the solid inner core meets the super hot liquid outer core. The molten metal flows around it, and combined with the tug of an uneven gravity field, likely warps its edges. Scientists can't drill down to the core to check this theory. It's 3,200 miles below the surface. But they can track seismic waves from earthquakes as they ripple through Earth. They measure how these shock waves bend, slow down, or speed up, and it can help figure out what the inner core is made of and how it moves. That's probably how they know that the solid inner core is slowly growing, freezing layer by layer of the liquid outer core. But don't worry, it'll take billions of years to fully solidify. By that point, life on Earth would probably already be gone anyway. The sun's gonna swallow our planet long before the inner core stops moving. But let's get back to the topic that, I bet, worries you most. What if Earth's magnetic field just vanished one day? Well, the planet would be hit by a storm of charged particles from the sun. Satellites would start glitching and power grids would go down. We would get zapped with higher levels of UV radiation, the kind that can cause all kinds of serious health issues. In short, it wouldn't be instant doom, but life would get a lot trickier. Luckily, now we know that a magnetic field doesn't just vanish overnight, but ours has been slowly weakening for over a century. So what would life on a planet with a super weak magnetic field look like? You would just have to throw away your compass. It wouldn't point north anymore, just towards the nearest patch of strongest magnetism, wherever that may be. The northern and southern lights would go insane, appearing closer to the equator, all because charged solar particles would be able to get through the atmosphere more easily. Satellites would be under constant attack. Solar particles would fry their electronics, mess with memory, and cause what scientists call single-event upsets. High-frequency radio signals would also get scrambled, thanks to free electrons in the ionosphere. Over time, the solar wind could even start wearing down the ozone layer, leaving us all more exposed to UV radiation. Now, let's decrease the level of drama. A magnetic field isn't the only thing keeping a planet alive. Mars did lose its magnetic shield about 4 billion years ago, and most of its atmosphere got blown away. But Venus has no global magnetic field, but still has a thick atmosphere. If Earth lost its magnetic field completely, we wouldn't instantly vanish, but life would definitely change, and we would have to get used to these drastic changes.
Just when you think space couldn't get any more weirder? Hey, check my grammar. The universe throws a curveball in the form of a giant glowing bubble that's too perfect to be real. Astronomers have spotted something strange drifting through our galaxy. And it's not a rogue planet, which is a space body the size of a planet that doesn't orbit any star. It's not a star itself either. It's not even your average supernova remnant. It's a perfectly round sphere, and scientists are stunned. Astronomers were going through data from a super powerful radio telescope when they spotted something that looked like a perfect round bubble. At first, they thought it was the leftovers from a massive star explosion called a supernova. But the weird part was that the object was too perfect. Normally, such explosions leave behind messy, uneven clouds. And the newly discovered one looked like someone had drawn it with a compass. The scientists named the space bubble teleos, which means perfect in ancient Greek. They've already looked at all the possible explanations, but none of them really make sense yet. This strange space body was discovered thanks to a telescope in Australia called ASCAP. It's been scanning the sky and finding all kinds of weird circular objects. This research was part of a project called the Evolutionary Map of the Universe. Some of the faraway circles, known as ORCs, which is short for odd radio circles, have already puzzled scientists. But this one is different because it's inside our own galaxy. At the same time, even though Teleos is technically closer to us, scientists can't quite figure out how close it is. And that's making it harder to understand where it came from or how it formed. The researchers have taken an even closer look at this strange space bubble and found something super odd. It only gives off a very faint glow and only in radio waves, not in visible light or X-rays. Based on that glow, they figured it's most likely the leftover shell of a massive star explosion called a Type Ia supernova, one of the brightest and most powerful kinds of explosions in the universe. This kind of explosion happens like this. A super-dense dead star called a white dwarf starts stealing material from a nearby star. It keeps sucking in stuff until it just can't handle the weight anymore, then it blows up in a huge burst of energy. Now that part makes sense. But figuring out how far away is this thing? Strangely, it's not so easy. Scientists have run the numbers and ended up with two possible distances for Teleos. Either it's around 7,175 light-years away, or it's much farther, about 25,114 light-years away, give or take. Depending on which distance is right, the size of the bubble could be vastly different. If it's closer, then it's about 46 light-years wide. That would make it a pretty young supernova remnant, maybe less than 1,000 years old. But if it's farther away, then it's a giant 157 light-years across, which could be more than 10,000 years old. So, which one is it? That's where things get tricky. Scientists have models that tell us how these supernova leftovers should behave. And one of the most important things they expect to see is X-rays. But you might remember that Teleos doesn't show any, not a single X-ray in sight. That's the big mystery. How can something that should be glowing with X-rays be totally silent? It just doesn't add up and leaves the scientists very puzzled. Another idea the scientists are considering is that Teleos might not be a regular supernova remnant at all. Instead, it might be the leftovers from a rarer kind of explosion called a Type Lax supernova. And this one? It's extra weird. In a normal Type La supernova, the white dwarf star blows itself to bits. But in a Type Lax supernova, it doesn't get totally destroyed. It kind of survives, turning into a zombie star. Ooh. It's damaged, but it's still around. This would actually explain a lot about how Teleos looks and glows. But in this case, it would have to be much closer to us, only about 3,262 light-years away. That would also make it a lot smaller, about 11 light-years wide. The coolest thing here is that there's actually a star at that distance that could be the zombie star that caused all this. But, and it's a big but, like I have, when scientists use other ways to try and measure how far away Teleos is, none of them agree that it could be this close. So, sadly, this theory hits a bit of a wall. Then there's another strange thing. Teleos' nearly perfect spherical shape. That's not normal. Usually supernova explosions are kind of messy and uneven. The blast might push into clouds of space dust or gas, or parts of the explosion might move faster than others. Eventually, the shell that forms gets all lumpy or starts to break apart. But in this case, the object is almost perfectly round, like a balloon, and that's super rare. The only way something could stay this neat and round is if it exploded in a very empty part of space and expanded smoothly in all directions. That's actually not impossible, just really, really rare. Now, considering its unique, probably unnatural shape, could Teleos be an artificial object? Could it be a Dyson sphere? That's a hypothetical megastructure that could completely surround a star and harvest all of its energy. At first, this idea was supposed to explain how we might detect intelligent extraterrestrial life, by spotting the energy they use rather than waiting for them to send us a message. You see, here on Earth, we only receive a tiny bit of the sun's energy. Meanwhile, a whopping 386 billion megawatts are shooting out into space in all directions. Not to waste such a giant amount of energy, a civilization could build a Dyson sphere, or more realistically, a Dyson swarm, loads of solar panels orbiting the star. It would help them capture every bit of that power to run their planet, technology, AI systems, and maybe even space travel across galaxies. To understand just how advanced a Dyson sphere-building species would have to be, scientists use the Kardashev scale. It ranks civilizations by how much energy they can use. Type 1 can use all the energy available on their home planet. Spoiler, we're not even there yet. Type 2 can harness all the energy from their star. That's the Dyson sphere level. Type 3 can use energy from an entire galaxy. Think Dyson spheres around every star and even extracting energy from black holes. Right now, Earth's civilization ranks about type 0.7449, give or take. That means that we haven't even maxed out the energy available to us on Earth, including fossil fuels, renewables, and nuclear power. We're still taking baby steps on this cosmic scale. Anyway, the problem with the theory that our perfectly shaped object could be a Dyson sphere is that this example of super advanced technology would give off heat. In other words, there would be thermal infrared radiation, and the object would be unusually bright in the infrared. This could be a sign that something artificial is absorbing the star's energy and re-emitting it as heat. But the scientists have found no heat signatures or anything like that when observing Teleos. So, do we have the final answer? Not yet. The scientists have looked at all the existing clues, how bright the thing is, how big it looks, and how far it might be. And none of the possibilities are totally perfect. Each idea has a problem, especially the fact that we're not observing any X-rays, which should be there according to the usual rules. They still think that regular type LA supernova idea is the best bet for now, but they're not 100% sure. There's just not enough proof to say for certain. So, the mystery continues. The team says we'll need more powerful and detailed observations to really figure out what happened here. But in any case, if something like Teleos can exist, what else is out there, waiting to challenge everything we know about the universe? So, astronomers have spotted about a dozen mysterious explosions in space, and no one really knows what they are or why they're happening. At the moment, they occur about 200 million light-years away. But what if, one day, they get much closer to our planet? Now, this all started back in 2018. One day, telescopes saw a giant boom far away in space. That explosion was incredibly bright, about 100 times brighter than a normal star explosion, called a supernova. The strange thing was that normal supernovae take weeks or even months to fade away. But that one went from kaboom to poof, gone, in just a few days. It got extremely hot and huge, about the size of our whole solar system, and then vanished like it never happened. Scientists were seriously confused. Now, they named the explosion the Cow, because its official name was too long and not exciting at all. Since then, astronomers have been hunting for more of those oddball explosions. And indeed, they've found a few more and given them weird animal names too. That's how we got the koala in 2018, the camel in 2020, the Tasmanian devil in 2022, and the finch, or the fawn, in 2023. All of those are part of a strange group called LFBOTs. That stands for Luminous Fast Blue Optical Transients. Luminous means they're super bright. Fast because they happen and disappear really quickly. The blue color results from their temperature. They're super hot, like 72,000 degrees Fahrenheit. And optical transients means they show up in visible light and don't stick around for long. Even now, the scientists are still scratching their heads, trying to figure out what's causing these bizarre space flashes. It's like the universe is playing a mysterious game, and no one knows the rules yet. At first, scientists thought those space explosions were failed supernovae. That's when a star tries to explode but instead collapses in on itself, kind of like a balloon popping inward. That collapse can create a black hole in the middle that will eat the star from the inside out. But recently, a new theory has popped up, and it's even cooler and creepier. It has to do with black holes, super squished leftovers from exploded stars. They're so powerful that even light can't escape their clutches if it gets too close. That's why they're totally dark and impossible to see directly. Now, some space scientists think that unknown black holes, not too big and not too small, might be pulling in stars that get too close, which produces those explosions. Such holes are called intermediate mass black holes, and no one has actually seen one of those yet. They're like space's biggest mysteries, and we'll try to solve it in a few minutes. But after that, you need to know that a new left-bot has shown up in space. It was spotted by a telescope in Liverpool and is currently called AT 2024 WPP. Yep, scientists still haven't picked an animal name, but they're thinking maybe the wasp. What do you think of this name? Share it in the comments. Anyway, one of the scientists is sure that it's the best one since the cow. The most recent space explosion is super interesting and extremely bright, like me. Maybe the brightest one since this whole left-bot thing began in 2018. This new WASP boom also doesn't look like a failed supernova. And still, scientists are checking all the data just to be sure. Now, scientists are pretty sure mid-sized black holes that could cause the explosions must exist somewhere. It's like knowing a secret creature might be hiding in space, but no one has gotten a photo of it yet. Some scientists think that this idea is the most exciting, and that it might even help explain dark matter, one of the biggest mysteries in the entire universe. Well, whatever the truth is, a recent discovery might shed light on the existence of mid-sized black holes. The thing is, when it comes to black holes, space has a few different sizes: small, super huge, and something in the middle. The small ones are called stellar mass black holes. They're around 5 to 50 times heavier than our Sun. The giant ones are called supermassive black holes. Makes sense. They're millions or even billions of times heavier than the Sun. They usually hang out in the middle of galaxies. And then there's the mysterious kind in between, called intermediate mass black holes. Those are like the missing link of black holes. Scientists are pretty sure they should exist, but we barely know anything about them, like where they came from, how they grow, or what they're made of. Good news, that mystery might finally be getting solved. Thanks to several new studies, scientists now have some exciting new clues. Researchers have found waves in space, which are called gravitational waves, that seem to come from black holes smashing into each other. And not just any black holes, but ones that are 100 to 300 times heavier than the Sun, which may mean that they're those mysterious mid-sized black holes. Plus, those are the biggest black hole collisions we've ever recorded on Earth. Now, black holes are like space fossils, super old history clues. And those newly discovered black holes could tell us about the first stars that ever lit up the universe. The problem lies in the fact that our tools on Earth, like LIGO, which stands for Laser Interferometer Gravitational Wave Observatory, only catch a tiny moment of these black holes crashing together, literally just a split second. That makes it tough to figure out where those medium-sized black holes come from. So, scientists have a new plan. One scientific lab is getting ready for a future space mission called LISA, short for Laser Interferometer Space Antenna. It's a cool space project by NASA and the European Space Agency, launching in the late 2030s. LISA will float in space and be able to catch the whole story of black hole crashes, not just the final boom. It will track black holes years before they crash into each other. And, if all goes well, we might finally figure out where these mysterious black holes come from and learn even more about how our universe began. So you might be wondering about how LISA will do it. Remember we talked about ripples dashing through space called gravitational waves? Black holes crashing into each other could send them out. Well, LISA is being built to listen for such waves. It'll float in space and look for all kinds of cosmic shakeups, Not just huge ones, but also smaller black holes spinning around giant ones. Now, why do gravitational waves matter? A lot of space stuff is too dark to see with regular telescopes, since no light comes from it at all. But gravitational waves don't care about light. They go through everything, telling us about the secrets hiding in the dark parts of the universe. By studying them, scientists hope to learn about things we've never seen before, like black holes, or what really happened at the very start of the universe, and maybe even things we don't know exist yet. Lisa will help us figure out how the universe began, how it's changing, and what it's made of. Now, getting back to those black hole collisions, finding them isn't easy. But researchers have come up with a smart solution. They're using artificial intelligence to make sure the signals from space aren't messed up by noise from Earth or the machines themselves. This work was part of a project focused on combining AI with space science. Scientists are getting more confident that intermediate mass black holes, the ones in between small and supermassive, are real. And they might be some of the most exciting things we can study using gravitational waves, both from Earth and from space. So the next big step? Looking to the Moon. Future detectors placed on the lunar surface could be even better at catching certain types of space waves, especially ones that Earth-based machines might miss. That would help scientists figure out where those black holes dwell in space. Besides this research, scientists are also planning human exploration of the Moon. They're helping NASA choose the best spots for future missions, focusing on big science goals like solar physics, space weather, and how the universe works. Right now is a super exciting time, not just for studying black holes, but also for connecting space exploration and science.